Bismillah Rahman Rahim. Assalamu alaikum. Welcome to ASTC. So, in this video, we will be starting with some practice questions related to our first lecture that we have covered in the previous video. Okay, so in the previous video, we have covered a number of different concepts. We studied about what is domain, what is range, what are the mapping diagrams, and how can we calculate range from a given domain of a function. All right, so let's start. Also, we studied about different types of functions that we have. So the first thing that we have to write down over here is that what is a domain? So domain are just the x values, okay, which are the input to a given function. Function is the equation that is given to you in the question. All right. The second is range. Range are the y values, which are the output of a function. Okay, so both domain so the domain tells you that what are the values that x can take for a particular given equation. Range tells you that what will be the y values as the output based on the input that you have given to the function. Okay, so range is the output, the y values, and domain is the input, which are the x values. Okay, that's the first thing. The second concept that we have to write down over here is that functions are of two types. They can be one to one, where for each value of domain you have one value of range. So we can say that one value of domain can be mapped exactly onto one element of the range. Okay, and then we also have another type of function which is many to one. In this case, we can have more than one domain values, but they both will be mapped exactly to the same range value. Okay, and we saw an example that the linear functions, the straight line functions, which are of the form y equals to mx plus c, they can be an example of one-to-one function. Obviously, there are other examples as well, but this is one of the examples. Then for many to one, we can say a quadratic equation is one of the examples which is relevant to this one. Because if I put, let's say, x is equal to minus 2, I would get 4. If I put x is equal to positive 2, I would still get 4. So you see, for two different domain values, I'm getting the same range value. So in order for a mapping to be called a function, okay, this is what we call mapping. The condition is that the range should always have just one value. Okay, now based on this concept, we will look at question number 1. Which of the following mappings show a function? So let us see. In question 1 part A, we have a domain, okay, and we can see that each domain value is being mapped exactly onto one range value. So for this one, for the first one, so this one domain value is mapped onto one range value. Okay, then over here we have two domain values which are mapped to one range value. Okay, so as long as we have single range value for the given domain, then this will be called a function. So this is a mixture of what we call a one-to-one and a many-to-one. Okay, so A is one of them. Let's take a look at B. B is exactly one-to-one because you can see that one element of domain is mapped onto one element of range in all three of them. So B is also a function. In C, we can see that again we have one-to-one function. Okay, why? Because over here you can see that okay, let me write this down over here. This is many to one. Okay, so for example, why we can have one range value for this domain. Let's say maybe the domain might be 0, x is equal to 0, so that is going to map only on one value of range, right? So this one would be a many to one. This is going to be one to one. This one is also going to be one to one. All right. And right, so this is also a function because for each domain value you have only one range value. So C is also a function. Okay, what about D? Now if you look for D, for one domain value you're getting two values in range. Okay, so this is not a function, because what is a requirement for a function to be called a function? It is that you must have only one value in the range for one or more domain values. You cannot have, for a single domain value you cannot have two range values. That's the rule. Okay, you will not call that a function, we will call that a relationship between the variables. Okay, so therefore our answer will be just A, B and C. These are the functions. And as for this one, we can call a relationship, okay, between X and Y. All right, question number 2. Give the domain and range of each of the following functions. So this is a question that is given to you, that f of x equals 2x minus 1 and x is between minus 1 and 3. Now this question tests your understanding of what do we mean by domain and what do we mean by range. So as we have told, as we have studied before, that domain are the x values. So therefore this interval that is given to you, this is the domain. So I'm just going to directly write this down. Okay, this is going to be my domain values. Now if you have if you have a linear function, you have a straight line graph. Okay, it goes something like this, right? It might go something like this. So that means you can see if they have given you that x is minus 1, so let's say this is minus 1 over here, and x is 3, so this is 3 over here. So we can directly plug in these values of x into my function, and I can find out that what is the corresponding y value. Okay, so what do I mean by that? Let's see. When x is equal to minus 1, because the range is going to be this one, right? The lowest y value, okay, and the highest y values. This is going to be my range of the function. So therefore, when x is equal to 1, I'm going to write down f of minus 1. So instead of x, now I'm going to plug in the value of minus 1 into it. So f of minus 1 will be 2 times minus 1, which will be minus 2 minus 1, which is going to be minus 3. Okay, that is the first one. Then I'm going to take the second value, which is x equals to 3, and then I'm going to work out what is f of 3. So that would be 2 times 3 minus 1. So instead of x, now I'm plugging in the value of 3. So this becomes 2 times 3 is 6 minus 1, that is equal to 5. So here we have found out that when x is equal to 3, this is 5. And when x is equal to minus 1, this is minus 3. Okay. Therefore, my range is going to be that f of x is between minus 3 and 5. Okay. So that's how you have to solve this question. Now, is it important for us to draw the sketch? No, not really. But it helps you visualize what's going on. Okay, so you have to understand the concept. So if you do understand the concept, you don't have to draw the diagram. Okay. All right, part B is f of x equals 3x plus 2. Okay, and the values of x given are minus 4 and 0. So these are the boundaries. We can say that x is between minus 4 and 0. Again, this is going to be a straight line graph like this. So I have to just find out what is the y value over here and what is the y value over here. So we just plug in the values. So now you will get an idea that for straight line graphs, all you have to do is just plug in the boundary values into your function. So I'm going to write that when x is equal to minus 4, f of minus 4 is equal to 3 times minus 4 plus 2. This is just a notation, okay? Because look, originally this is x, so you have x over here. If I want to plug in 4 minus 4 over here, that means I'm going to write down minus 4 over here as well. So basically what am I saying? I'm saying that input the value of minus 4 into your function. Okay, that is your input. Give this input to the function. So that's what this statement means. Okay. All right, so 3 times minus 4, that will be minus 12 plus 2, which is equal to minus 10. The second one is that when x is equal to 0, so f of 0 will be 3 times 0 plus 2. 3 times 0, that is 0 plus 2, which is equal to 2. Therefore, your range will be that f of x is between minus 10 and 2. All right. So the domain will be x is between minus 4 and 0 inclusive. And because these values are inclusive, therefore, in your range, these boundary values will also be inclusive. Okay. All right. Let's move to part C now. So again, we have a linear function and the given domain is that x is between minus 4 and 4. So let me write down the domain first. So x is between minus 4 and 4. So when x is equal to minus 4, f of minus 4 equals, now look, this minus sign over here, this is the minus of the formula itself, of the equation. Then we have another we have another negative sign, which is for the x value itself. So first I'm going to write down this negative value, which is part of the function. Then in place of x, I'm going to substitute minus 4. So that should come inside a bracket. Okay. Then after that, plus 4. So minus minus plus. So we have 4 plus 4. That gives us 8. Okay. Secondly, the value of x is positive 4. So in this case, now this negative sign, that is part of the equation, and then the value of x is 4. So this becomes minus 4 plus 4, which is equal to 0. Now you're going to notice something, that when I give a negative value to x, I'm getting a positive value, a higher value. And if I'm plugging in a higher value of x, okay, I'm getting a lower value of y. Why is that the case? Because this graph is a decline. See, you can see that there's a negative sign over here. So that means the gradient is negative. So from left to right, it is going downhill. All right. And therefore, for the value of x equals to 4, so let's say if I quickly draw a grid over here. So this equation is this line passes something like this. Okay. Let me draw it again. Something like that. So this is 4, or rather, yeah, okay. So this should be 4, and over here we have minus 4. So what are the values? Because my domain is restricted to 4 and minus 4, I'm going to ignore this part because this goes beyond 4, right? So over here, when x is equal to 4, the value of y is going to be 0, and you can see that it's lying on the x-axis. And when it is minus 4, it has a higher value over here, which is 8. So that is why my range is going to be that f of x is between 0 and 8. Okay, so that's how you have to work this out. So it's not necessary that because look, this is minus 4, this is not the corresponding value of that range. So we don't work that we don't work it out in that way, because at minus 4 you got 8, which was the highest value. So for the lowest domain, you're getting the highest range. So that is why you must keep them separate. Okay, so when we are trying to work out the range, you work out both the boundary values, and then accordingly you have to write this down. All right, so that is the end of part C. Part D is x squared plus 2, okay, and x is between minus 3 and 3. Now see, there here we have a quadratic equation. Now in a quadratic equation, there's something which is a bit different, okay, and let's see what do I mean by that. First of all, let me just plug in the boundary values, just like how we are doing in the previous questions. So when x is equal to minus 3, So f of minus 3 is minus 3 whole square plus 2. So that would be 9 plus 2, and that would be 11. When x is equal to minus 3, f of 3 is 3 square plus 2. That gives us 9 plus 2, and that is equal to 11. Now you see you're getting a fixed value. This is not a range, this is just one single value. Range always tells you a range, right? What do you mean by a range? A set of values. Okay, so it is giving you an interval that, okay, my y is going to lie between these two values. So over here there's a problem, and this problem exists because if I draw a quick sketch over here of this graph, so this graph should look something like this. Okay, now how do we know that this looks like this? Now for some of you who have covered the chapter in graphs, about graphs, they know why the graph looks like this. And for some of you who haven't covered it yet, don't worry, we will cover it later. Okay, so I'm telling you that this is how it looks like, so just trust me. So over here, this is how the graph looks like. Now you can see the graph is symmetrical. So if I take this point, this is 3, and if I take this point, this is minus 3. And for these two values, you're getting the same value of y, which is 11. That is why when I plug in the value of 3, I'm getting 11. When I plug in the value of minus 3, I'm still getting 11. But what is the lowest value? If I want to find the range, I'm looking for the lowest value. The lowest value occurs over here. This is the lowest y value, and that is occurring when x is equal to 0. Okay, so we are going to take another value of x, which is x is equal to 0. So f of 0 is equal to 0 square plus 2, hence that is 2. So therefore the range is going to be f of x is between 2 and 11, whereas the domain was between minus 3 and 3. Okay, so obviously once we have studied how to sketch the quadratic graphs, then you might know what to do. You have to draw a sketch for quadratic curves. So you have to identify what is this point. Okay, this is what we call the turning point of the graph, because graph turns over here, is going in this direction like this, and then at this point it starts to turn and move upwards. Okay, this is why we call this a turning point. Okay. All right, and then the next one is f of x equals x squared plus 2. So again, we have a similar situation. Actually, we don't have a similar situation. Look over here. It says x is a real number. That's all that it has told you. If you remember during our lecture, okay, in the previous video, we studied that when it tells you that x is a real number, it means x can take any value up to infinity, positive or negative, because he hasn't defined anything here. So how do we express that? We say x belongs to, this symbol means belongs to, and this is all real values. So that means x can be positive, x can be negative, x can be a whole number, x can be a decimal, x can be a fraction, it can be anything. Okay, so that is what we mean by that. So again, if I draw a sketch of this graph, so this graph should look something like this. It is the same equation, if you notice, as the previous one. So the graph looks something like this. So now it is continuing up to infinity. So it's going to go continue up to infinite values of minus x, and over here is going to continue up to infinite values of x. Okay, so what would be the range? The range is the y value, right? There's something that you can notice, that whether the graph extends to the right hand side, that means it is continuing all the way up to infinity, okay, in this direction, or it is continuing all the way in this direction. There's something quite prominent about this, that the y value is always going to be above this point. Okay, so from here we can see that my f of x is greater than or equal to 2. So this is what we can notice. Now let me quickly write some pointers. So this is the graph of f of x. Okay, that's what it looks like. And here are some pointers. x can take all real values. Okay, real values means positive, negative, integers, decimals, etc. Okay, however, y must be greater than or equal to 2. All right, so therefore the range is going to be this. All right, let's take a look at the next one, part F. Now this is also a similar equation, but if you notice something, that there's a negative sign over here. Now just like when we draw a straight line graph, okay, so this is a straight line graph, y equals to x, and this is a line which goes downhill, which is y equals to minus x. Okay, this is the condition for straight line graphs. Similar to this concept, if I have y equals to x square, my curve looks like this. Okay, a happy face. And if I have y equals to minus x square, my curve looks like this, which is a sad face. Okay, so because now over here you have a minus x square, so therefore the graph should look something like this. Okay, so let us first work out what are the values for each of these domain values. So when x is equal to 0, f of 0 will be 0 square plus 2, so that is going to give me 2. When x is equal to 2, f of 2 will be minus 2 square, sorry, my bad. The value that we have to take is 4, not 2. Okay, so when x is equal to 4, f of 4 is equal to minus 4 square plus 2. Okay, so that would give me minus 16 plus 2, and therefore that would be minus 14. So what does it tell you? That if the shape of my graph is going to be something like this, so this is going to be, because my domain is between what? Between 0. So this is 0, and suppose this is 4. Okay, so over here at 4, what was the value that we got? That was minus 14. So minus 14 would be here. And when x was 0, what was the y value? That was 2. So the range is going to be between 2 and minus 14. So I'm going to write down f of x is between minus 14. The lowest value comes on left hand side, highest comes on the right hand side. Okay, and the domain is between 0 and 4. All right, then the last one is part G. F of x equals x cubed minus 2. So over here, when x is equal to minus 3, f of minus 3 will be minus 3 whole cubed minus 2. So minus 3 whole cubed would be minus 27 minus 2 equals to minus 29. Okay, then when x is equal to 1, f of 1 means 1 cubed minus 2, that is 1 minus 2, that is minus 1. So the domain is that x is between minus 3 and 1. Okay, and the range would be that f of x is between minus 29 and minus 1. Okay, and this is what we call a cubic function. Okay, when you have x cube in your equation, that is a cubic function. All right, question number 3. The domain of f of x is minus 3, 0, and 2. So here you have been given individual values. In the previous questions, we were given the interval, right? That the domain can have any value between the given range. But here they have told you that x can take only these three values. And this is your f of x. Find the range of f of x. So here all we have to do is we have to find the individual x values. Sorry, we have to find the individual y values of these corresponding x values. So when x is equal to minus 3, f of minus 3 will be 3 times minus 3 minus 5. That would be minus 9 minus 5, which is minus 14. That's the first one. Okay, when x is equal to 0, so f of 0 will be 3 times 0 minus 5. 3 times 0 is 0, and 0 minus 5 would be minus 5. Then the last domain value is 2. So when x is equal to 2, f of 2 will be 3 times 2 minus 5. So that would be 6 minus 5, which is equal to 1. So therefore, how am I going to write this down? They have already given you the curly brackets. All you have to do is just write the values that you got. So minus 14, then we got minus 5, and then we got 1. Okay. B part. G of x is equal to 2 over x minus 4. Draw a mapping diagram for the function g of x equals 2 upon x minus 4 with the domain 0 to 6. Now, what is a mapping diagram? If you go back to question, page number 2, so you see these diagrams are called the mapping diagrams. Okay, so what do we do in this case? We draw two oval shapes. This one represents domain, and then we draw another oval shape. This one is your range. Okay, now the domain values are 0, 2, and 6. What will be the corresponding range values? Let's work it out on this side. So f of 0 will be 2 over 0 minus 4. I'm going to plug in the value. Sorry, this is not f, this is g. This is a different function, right? So instead of x, I'm going to plug in the value of 0. So this would be 2 over minus 4. That would be minus 1 upon 2. Okay. Then for the second one, we have g of 2. That is going to be 2 over 2 minus 4. So that would be 2 over minus 2. When you simplify this, you get minus 1. And g of 6 will be 2 over 6 minus 4. So we have 2 over 2, which is equal to 1. So for the value of domain, so when x is equal to 0, your value in range, your y value is minus half. For x equals to 2, you have minus 1, and for 0 you have, sorry, for 6 you have 1. Okay, and we're going to show this with the arrows. Okay, this is a complete mapping diagram. Okay, so let me write this down. So this is domain of g of x, and this is range of g of x. Okay, now the last part is explain why the domain of this function cannot include x equals to 4. Now it says that why the domain cannot take the value of 4. That means that why I cannot plug in the value of 4 into this equation. Okay, let's try what's going to happen if I do that. If I write g of 4, that would be 2 over 4 minus 4, which would be 2 upon 0. So here the function becomes undefined because you cannot divide a number by 0. If you plug this in your calculator, you would get a math error. Okay, so therefore we're going to say that with x is equal to 4, the function becomes undefined. Okay, you can say that, or you can also say that with x is equal to 4, the denominator becomes 0. Okay, so you can write either one of these statements. We can say with x is equal to 4 the function becomes undefined, or we can say that with x equals to 4 the denominator becomes 0. Okay, so this is the end of our lecture. So I hope that everything is clear so far, and with that being said, I'll see you in the next video. Take care.